Good day to everyone. So this will be the continuation of my discussion. Again, my discussion is earlier is about the language properties, and now also assigned task for me is to discuss about the brain and the language development. Okay. So again, the subject is ELT 200, the development of language acquisition and learning, and the continuation of my topic, as I said, brain and language development. We need to understand how language is represented and processed in the brain. Okay? Have you ever wondered if you're going to hear this word? Okay, how do you feel about that? What part of your brain to actually process? Okay, if you actually do this and do that, okay, you process the words, the language, you acquire the language. What actually part of your brain actually process? So we will be exploring on that. But first, our objectives are differentiate neurolinguistics and psycholinguistics, because this has something to do with the brain and the acquisition of the language. Second one, enumerate the cognitive functions of different hemispheres of the brain. And then third one, explain the language development milestone and its relevance to the language centers of the brain. Now, let's talk about psycholinguistics. When we say psycholinguistics, it means the acquisition, the storage, comprehension, and production of the language. When we acquire the language, whatever language it is, when we store the language in our mind, comprehend the language, we understand what is meant by these words in this language, and we produce the language or we use the language on communication, we call that psycholinguistic. It is the study of those. We call that psycholinguistics. Whereas on the other hand, when we say neurolinguistics, this is a branch of psycholinguistics that deals with the language and the brain. Okay, so neurolinguistics is one of the branches of the psycholinguistics. So basically, psycholinguistics is a general, and then specific or branch or sub is the neurolinguistic, which only talking about the language and how do the brain process that language. Okay, now let's explore the brain. Cerebral cortex. It is a 1/4 inch thick membrane covering the brain. Okay, what are the functions of the cerebral cortex? Consciousness. Okay, when we're very conscious about how do we look like, our body, we think like we're fat, we're very conscious about what will be our grade, we're very conscious about what I'm going to say to this person, so things like that. If you're very conscious about your surroundings or things, no, your cerebral cortex is actually processing that. Thinking as well, of course, brain, we're always talking about the cognitive or the thinking. And then learning, the cerebral cortex. When you are learning new things, you learn from school, you learn from different instances, actually cerebral cortex is really working. And then emotions. When you feel like you're hurt with the words of your friend, okay, you're hurt with this, what you see, what you actually perceive, your cerebral cortex is really working. And of course, talking about the language. Of course, our topic is all about the language. And then the function of the brain, the function of the brain that actually processes the language. Now, again, language is always processed in your cerebral cortex. Okay? It constitutes the difference between humans and other animals, because cerebral cortex is one of the part of the brain that actually makes us distinct from the animals. Okay? And then we have the corpus callosum. When we say corpus callosum, bundle of nerve fibers that connects your brain or right hemisphere of the brain to the left hemisphere of the brain. Okay? Let's go with this term, lateralization. Okay? When we say lateralization, talking about the hemisphere. Each hemisphere specializes in different functions, referred to as lateralization. Okay, lateralization. We have the right hemisphere, the left hemisphere. In the right hemisphere, it processes holistic reasoning. So when we are reasoning holistically, right hemisphere is working. Music processing. When you're a musician, you're a singer, you love music, you like hearing this one and that one, your right hemisphere is concerned about that. Processing of non-linguistic sounds, visual and spatial processing. Whereas on the other hand, left hemisphere, analytical reasoning. Okay, we're very good in reasoning, analyzing things, then give reasons, temporal ordering, arithmetic as well, and then of course, language processing is mainly processed in your left hemisphere. Okay? As continuation, most of the right-handers, okay, people who are using the right hand, commonly left hemisphere dominance for the language. Again, commonly people who are right or using the right hand, left hemisphere of their brain is dominance for the language. Whereas the left-handed people generally less lateralized for the language, okay? Which means they're not that invoked when it comes to language because they're left-handed. No. Do we have this evidence for lateralization? Language damage are more likely following the left hemisphere, okay? So commonly when there is damage in the language, commonly left hemisphere of your brain is actually affected. 70% versus 1%. Okay, that's so far. We have this dichotic test, dichotic listening test, split brain patients. Let's talk about this too. Dichotic listening test. So when you hear the word two in your right, you hear the three on your left, ask yourself, which one do you think is more accurately reported? Which among these two words you actually really hear, clear, and recognize? Okay? So two different stimuli are presented simultaneously through earphones to the left and right ears. The listeners are asked to say what they hear. Okay? So actually, that's what we call dichotic listening. Okay? We are processing, or let's understand moreover with the processing of the left and right hemisphere of the brain. Contralateralization. When we say contralateralization, okay, the right sensory of our information, example, your right ear will be processed in your left brain, okay? And then left sensory information will be processed on your right hemisphere of the brain. That's what we call contralateral. Okay, the connection between the brain and the body are almost completely contralateral. Let's go further. Okay, let's talk about right ear advantage, or REA. So let's analyze this figure. The man is facing us, or the screen. We have the right hemisphere of the brain, which is for the non-linguistic sound processing, and then the left hemisphere of the brain is for language processing. Now, the right ear will hear two as a word, and the left ear hear the three, which is actually dominant, or which is actually heard and recognized. Okay, then the listeners can identify linguistic stimuli more accurately when presented to the right ear, which means this man may clearly identify or dominated to hear the word two, because it will go or process in the left hemisphere of the brain, which is concerning about the language processing. Okay, and then whereas in the left hemisphere of the brain, okay, and then using the left ear as an advantage, okay, left ear hearing the word ring, and then right ear hearing the word zzz. The left ear will recognize more, the ears will recognize more the word ring, because it will be processed by your right hemisphere of the brain, which is concerning about the non-linguistic sound processing. Okay? Again, let's review. The right hemisphere of the brain is on processing non-linguistic sound, and then right hemisphere of the brain is processing language. Okay? Again, left is for language, and then right is for non-linguistic sound. It's more of the sounds. Then we have this what we call split brain experiments. The hemisphere of the brain are connected by corpus callosum. Again, corpus callosum is brain is the fibers that connects the left and right hemisphere of the brain, and then this corpus callosum severed to prevent severe seizures. In the experiments, patients are blindfolded. For instance, they're holding an object both on the right and then the left. For example, a key. Okay, So this is just your key in the left hand. Okay, what do you think part of the brain will actually process the key in the right hand? This is what we call, diba, contra-lateralization. Okay, summary, key in the right hand, patient can name the object when they are in the keys in the right hand. When the keys in the left hand, patients are unable to name the object. Okay, why do you say so? Because in the right, again, because in the right, okay, in the right, it will process by the left, which is in language processing, and the left will be processed by the right hemisphere of the brain, which is in the non-linguistic processing. Okay, so let's talk about the language centers. What part of your brain usually really focuses in processing the different aspects of language? In the Broca's area is more of the speech production, syntactic information. Okay, in the angular gyrus integrates visual and auditory information, and then crucial for reading. So when children starts to read, okay, and then they're very visual, they're auditory, what they hear from their teacher, they will repeat it. Actually, the angular gyrus is really working. Okay, then Wernicke's area, language comprehension, when more of the reading, understanding the text, and then lexicon. Okay, again, the Broca's area, more of the speech production, syntactic information. In the angular gyrus, crucial for reading, integrates visual and auditory information. And then in Wernicke's area, language comprehension and lexicon. This is the center of the language development. Now, talking about the different developmental or the development milestones in language. In three months, they're mooing and then gurgling. If you're going to notice, if you have children, okay, children at home, and then they grew up in your home, you could actually observe this developmental milestone in language. Then 6 months, they start to bob or with bubbling. 12 months, first words, they have that one. In the first year of their lives, they could start mentioning the names of their, they could call their parents, okay? And then 18 months knows 5 to 40 words, regardless of the length of the word. At least they could mention or they could pronounce or know the 5 to 40 words. 2 years old, 150 to 300 words, 2 to 3 word sentences. So at least they could express themselves in a sentence. 2 years old, 3 years old, 900 to 1,000 words. Ask short questions. Okay, commonly these short questions are to express their needs. Okay, then 4 years old, 2,000 words, 5 word sentences plus, and then 5 years old identifies letters and longer sentences. That is why when a child reaches the 5 years of age, okay, commonly the parents could actually send the child in school, okay, because this is the right age actually in sending the child in school because they're mentally prepared, okay, and also as explained by this chart, by this developmental milestone development in the language, they are mentally prepared or ready to learn more about language, letters, identify the letters, making sounds out of the letters, and then write their name, read, okay, little by little. Okay, again, this is the developmental development or milestones in the language. Now, as a question, think and answer. What is the difference between neurolinguistic and psycholinguistics? Second one, what are the different cognitive functions of left and right hemisphere of the brain? And then third, explain the relevance of language development milestones to the language centers of the brain. Okay, so these are my references. Thank you very much, everyone, and have a good day.